Hello dear students, today's topic is sulfonation of benzene. The sulfonation of benzene is the example of electrophilic aromatic substitution reaction. Let's look at the reaction. Benzene react with sulfuric acid in presence of excess amount of sulfur trioxide, and this result into formation of benzene sulfonic acid. Now, though the reaction is taking place on the benzene ring, which is aromatic, it is called as aromatic reaction. And here is the substitution of the hydrogen as H plus ion from benzene with the sulfur trioxide as the electrophile. The reaction is called as electrophilic aromatic substitution reaction. Let's look at the mechanism of this reaction, which involve the first step, that is generation of the electrophile. Here, two molecules of sulfuric acid react in such a way that one of the sulfuric acid liberate proton, which is transferred over the hydroxyl group of other sulfuric acid molecule. Now, this leads to the formation of protonated sulfuric acid and the bisulfate ion. In the protonated sulfuric acid, here is the formation of H2O molecule. So this H2O molecule left the protonated sulfuric acid, and this gives formation of the HSO3 plus molecule along with formation of water molecule. Dear students, when the water molecule lost from the protonated sulfuric acid, the bond between the sulfur and oxygen is broken down, and the electron pair of this sulfur oxygen bond are taken by the oxygen of water molecule. Thus, the sulfur atom will become electron deficient in nature. When the HSO3 plus and water molecules are formed, the HSO3 plus molecule is strong, acidic enough to transfer proton. So thus there is the transfer of proton from this molecule to the water molecule, and this leads to the formation of sulfur trioxide, that is SO3, along with formation of hydronium ion, which is H3O plus. In sulfur trioxide, the sulfur atom is surrounded by 6 electrons only. 2 electrons of this sulfur oxygen bond, 2 electrons of sulfur oxygen coordinate bond, and the 2 electrons of other sulfur oxygen coordinate bond. So in total, the sulfur is surrounded by 6 electrons only. So to complete the octet, SO3 requires a pair of electron. So thus the sulfur trioxide molecule act as the electrophile, that is the species which is deficient in a pair of electron to complete its octet. So this electrophile then attack on the benzene ring to form the corresponding benzenonium ion, which is the intermediate carbocation formed by the attack of sulfur trioxide over the benzene ring. The sulfur trioxide act here as the Lewis acid because it is electron deficient, electron pair deficient rather, and the benzene ring act as the Lewis base because it is the source of pi electrons here. So when the sulfur to carbon bond is being formed, the carbon to hydrogen bond is being broken out. So during this process, the carbon atom, means this carbon atom, acquire a partial pentavalent character, that is the formation of the carbocation over the whole benzene ring, and that's why this molecule, or sorry, this ion is called as benzenonium ion. Though this benzenonium ion is unstable, it loses the proton as the H plus ion to the bisulfate ion. So the hydrogen, when transferred over the bisulfate ion, sulfuric acid molecule is formed, and this loss of proton from benzenonium ion leads to formation of benzene sulfonate ion, where there is a negative charge over the oxygen bonded with the sulfur. This benzene sulfonate ion is basic enough and it accepts a proton from the hydronium ion generated in the previous step. So the hydronium ion transfer a proton to the benzene sulfonate ion. So it is just a acid-base reaction where hydronium ion acts as an acid and benzene sulfonate ion act as a base. So this transfer of proton from hydronium ion to benzene sulfonate ion gives formation of benzene sulfonic acid. So dear students, in this way, benzene on reaction with sulfuric acid in presence of excess amount of sulfur trioxide leads to formation of benzene sulfonic acid. So that's all about the sulfonation of benzene. Thanks for watching this video. Please like, share and subscribe. Thank you.